Okay, here's my poster for sections 10.8 through 10.10, starting with 10.8. This was a short section that was on the halogenation of alkynes, and similar to the halogenation of alkenes that we did in Chapter 9, we can add a bromine or chlorine molecule across the pi bonds here. So if we do it with excess chlorine or bromine, then you're going to get an alkane with a tetra-substituted alkane, with all of these being chlorines or bromines. But if you do it with only one equivalent or one molecule of chlorine or bromine, you're going to end up with still a pi bond. So you're going to take your alkyne and turn it into an alkene, and you're going to get a mixture of products here. You're going to get either the trans, which would be the major product, or the cis product, where both chlorines are on the same side of the pi bond, which will be your minor product. And then that was it for 10.8. Not a whole lot there. 10.9, ozonolysis of alkynes. Again, this is when we're adding ozone in the presence of water, and we're going to cleave this this triple bond, and each of our carbons will have a double bond going to an oxygen and a single bond going to a hydroxyl group. So you have carboxylic acid. So you're going to have two molecules from one, cleaving that triple bond, and then turning your carbons into the carboxylic acid carbons. So two carboxylic acids when your alkyne is not terminal. If your alkyne is terminal, as it is in this one, and you use ozone and water, you're going to form one carboxylic acid, and then carbon dioxide will be your other product. So we're going to cleave the triple bond, and again, the carbon that has the alkyl group on it will turn into the carboxylic acid carbon, and then the carbon with just the hydrogen will be the carbon dioxide. That was 10.9, and then that was short. So 10.10 was on the alkylation of terminal alkynes. So this is a method where you would install an alkyl group on a terminal alkyne. So an example here, let's say we have an alkyne, and it's terminal because it's got the hydrogen on this right carbon. If we were to react it with the strong base, amide, again, deprotonating the hydrogen here, electrons push onto the carbon, we would have the alkanide ion as the product formed. Now, this alkanide ion, in the presence of an alkyl halide, in this case ethyl iodide, it'll act as a nucleophile, and it will attack the carbon, and the iodide will leave. And what we'll have here is this ethyl group attaching to the alkanide ion, which will give us this final product here. So it can add more of a carbon chain onto the alkyne that was present. Now, if you were to do this with acetylene, which is terminal on each end, then you can add alkyl groups to each side. So you could do this in one step with, again, our strong base, which would deprotonate one side, and then we could add, in this case, we have ethyl iodide again. We could add an ethyl group to one side, and then if we continue this process, we can deprotonate the other hydrogen, and we could just add, again, if this were ethyl iodide again, we could add another ethyl group to the other side. So we're adding, again, carbons to our alkyne chain. And that was alkylation of terminal alkynes. That was 10.10. And hopefully that kind of matches up with what you guys were thinking. And stay well, people.